Hey everybody, so in this video I'm going to show you how to find the nth term of an arithmetic sequence, and then we're going to use that nth term to find the 50th term in each of these sequences. So if we begin with question A, we've got the sequence 5, 8, 11, 14 and 17. So when we find the nth term, it's really important we understand what the variable n represents, and n is the position of each of these numbers within the sequence. So this number 5 is the first term in the sequence, so the n value would be 1. This 8 is the second term, the 11 is the third, 14th is the fourth term, and the 17 is the fifth term. Now what the nth term formula does, it creates a formula or a rule that will take us from the position to the value in that sequence. And we begin by finding the common difference between each of these terms. So you can see that the difference between the 8 and the 5 is 3. 8 plus 3 gives us 11. And then the same, add 3. And then 14 add 3 gives us 17. So this positive 3 is the common difference. So because our sequence goes up by 3, we need to multiply each of these n values by 3. So we create the 3 times tables. And when you multiply this n by 3, we get 3n. And now to go from the 3 to the 5, the 6 to the 8, the 9 to the 11, and so on, we need to add 2. So we're saying that the nth term for our sequence is 3n plus 2. And we can check this works. When n equals 4, we should get 14. And if we substitute this 4 into our formula, we get 3 lots of 4 plus 2, and 12 plus 2 does make 14. Okay? So to work out the 50th term, we substitute in n equals 50. We get 3 lots of 50 plus 2. 150 plus 2 is 152. So our 50th term in the sequence will have a value of 152. Okay, let's try question B. So now we have the sequence 33, 30, 27, 24, and 21. We know 33 is our first term, the 30 is our second, 27 is our third, and so on. The common difference will be the 30 take away the 33. This will give us minus 3. 30 take away 3 does give us 27. And 24 take away 3 is 21. So now we're looking at the negative 3 times tables. So 1 times negative 3 is negative 3, negative 6, negative 9, negative 12, and negative 15. So what we've done then is we've multiplied the n by negative 3. So we get negative 3n. And then to go from negative 3 to 33, negative 6 to 30, negative 9 to 27, and so on, we have to add 36. So our nth term will be minus 3n plus 36. Now with algebra, it's a good idea to not start with a negative, if that's possible. So we can say that this is equal to 36 minus 3n. And again, we'll just check this works. So when n equals 4, we get 36 minus 3n, which is 12, and this does give us 24, which it should. Okay? So when n equals 50, we've got 36 minus 3 lots of 50, which gives us 36 minus 150, which comes out as minus 114. Okay? So perhaps you want to try questions C and D yourself. You can pause the video, and when you come back, we'll go through the work solution. Okay, so welcome back if you had a go. So for question C, you can see the common difference is 4 add 5 makes 9, 9 add 5 will make 14, so this 5 is our common difference. So this means we're looking at the 5 times tables. So we've got 1 times 5, 2 times 5, 3 times 5, and so on. And when you multiply the n by 5, we get 5n. And then to go from the 5 to the 4, or the 10 to the 9, 15 to the 14, we need to take away the 1. So this will be our nth term. And the 50th term is when n equals 50. So we'll have 5 lots of 50 minus 1. 250 minus 1 will give us 249. Okay, so for question D, we'll work out outcome and difference as 18 take away 24, which is negative 6. So we're looking at the negative 6 times tables. 2 times negative 6 is negative 12. 3 times negative 6, negative 18. Negative 24, negative 30. When you multiply the n by negative 6, we get negative 6n. And then to go from the negative 6 to the 24, the negative 12 to the 18, and each of these terms, we have to add on 30. So our nth term, we can write as 30 minus 6n. And for the 50th term, we'll substitute this into a formula. So 30 minus 6 lots of 50, which gives us minus 270. Okay? Let's try some exam questions. Okay, so in this question, we're told that here are 4 terms of a sequence. We've been asked to work out an expression for the nth term, then to use the nth term to explain why 309 is not in the sequence, and then to find the term in the sequence which is nearest to 309. So the first thing we'll need to do is to work out the common difference, and 14 minus 8 is 6, or positive 6. 14 add 6 is 20, and 20 add 6 is 26. So we're looking at the 6 times tables. So we've got 6, 12, 18, and 24. And this will give us 6n. So then to go from the 6 to the 8, the 12 to the 14, the 18 to the 20, we need to add 2. So this will be the nth term, 6n plus 2. The question B, explain why 309 is not a term in the sequence. Well, if you notice that each of these terms are even, and the 309 is an odd, but we need to prove that this sequence can never have an odd number. So if we factorize the 2 out of this nth term, we know this will be equal to 2 lots of 3n plus 1. And when you multiply any term by 2, you'll always get an even number. So we know that every term in our sequence will always be even. So we can say then that every term will be even, and since 309 is odd, it will never appear in the sequence. Then for part C, find the term in the sequence which is nearest 309. So now we need to set up an equation. We know 6n plus 2 describes our sequence, and let's say this is equal to 309. Then we can solve this equation to find which position is closest to this number. So we'll take away 2 from both sides, so 6n will equal 307. We'll divide both sides by 6, so n will equal 51.17. So the term that this is nearest to will be the 51st term. And then to work out which term this is closest to, we'll substitute this back into the nth term. So we get 6 lots of 51 plus 2, and we get 308. So this will be the term nearest the 309, okay? Let's try one more question. Okay, so in this example, again we've been given the first 4 terms of a sequence. We've been asked to find an expression in terms of n for the nth term of a sequence, and then to write down an expression in terms of n for the n plus 1th term of a sequence. So perhaps you want to try this question yourself. You can pause the video, and when you come back, we'll go through the work solution. Okay, so welcome back if you had a go. So we'll work out our common difference. This will be the negative 4. So we're looking at the negative 4 times tables. We will have negative 4n, and then to go from negative 4 to 18, from negative 8 to 14, and so on, we need to add 22. So the nth term will be 22 minus 4n. You will still get full marks if you began with a negative 4n. For part B, to write down an expression for the n plus 1th term, we need to let n map on to n plus 1. Then all we do is we substitute this expression for n back into our nth term. So we have 22 minus 4 lots of n plus 1. We can expand out this bracket, minus 4n minus 4. This will give us 18 minus 4n. So this will be an expression for the n plus 1th term. Okay, so thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe. And you can download the full lesson and worksheet from my website, mrmathematics.com.